This is week 1, lesson 4. So far you've seen vectors written in this particular notation in Delta Math. All right, Delta Math really likes that notation. And that vector looks like this over here. And the reason it's named as 2, 5 is because of individual little unit vectors that are only 1 unit long. And there would be 2 of them, right? So I goes in this direction, that's I, and then J goes in that direction. So let me kind of zoom in a little bit. So on this one, if you're looking really close, this would be an I and another I, and then 1, 2, 3, 4, 5 J's. All right, so that's why that particular vector is named as 2, 5. But I want you to see that there are a couple other ways to name that, because even though Delta Math really likes that notation, the IB textbook doesn't really use it, and I don't use it as much. So the other 2 ways that mean the exact same thing would be 2I plus 5J. All right, that sort of involves those little individual unit vectors. And then you'll also see it as a column vector like this, 2, 5. Okay, and again, in all 3 of those cases, the number that comes first is talking about sort of the X direction, and the number that comes second, or lower in this case, is the Y direction. All right, so then, as I move this up, there's a couple examples. They want you to draw these vectors. Now, the great thing about vectors is it doesn't matter where you start. Right? You can start anywhere. There isn't really necessarily an origin. So if I'm asking you to draw 4i minus 2j, that means 4 in the x direction and negative 2 in the y direction. So I'm going to start right here. I'm going to go over 1, 2, 3, 4, negative 2 in the y direction, and connect. Again, I wish I had a straight edge, but it's a little hard to do on my iPad. All right, and then this one. Example number 2. So this one is the x direction. This is the y direction. Again, starting anywhere you want. In fact, you could draw 5 of these if you wanted. They'd all be considered equivalent. I'm going to start right here. I'm going to go left 1 for that. And I'm going to go up 6. 1, 2, 3, 4. And nope, I'm not putting it there. It doesn't fit. So I'm going to start a little lower. I'm going to go left 1 and up 1, 2, 3, 4, 5, 6. And draw my vector. All right, and then I think this might be my last example actually. Okay, so this one, notice that we're actually doing this one on actual graph paper with an origin. Okay, they want me to draw point A at negative 2, 5, so negative 2, 1, 2, 3, 4, 5, that's point A, and point B at 3, 3, 1, 2, 3, 1, 2, here's B. And then they want me to name vector AB. Now notice the order really makes a difference, okay? AB starts at A and heads towards B, okay? It heads towards B. And it says to name it in 2 ways, okay? Now keep in mind, vector AB could be here, right? I could put it over here, 1, 2, 3, 4, 5, 1, 2, 1, 2, 3, 4, 5, 1, 2, right? This would be the exact same vector. All right, again, I could draw it anywhere. It doesn't matter which quadrant it's in, right? It's the same vector because it has the same direction and the same magnitude. All right, so if I just count, you just even heard me do it a second or 2 ago, 1, 2, 3, 4, 5 in the x direction, and then negative 2 in the j direction. I could name it like that. Or I could name it as a column vector as 5, negative 2. What if, right? I'm just playing devil's advocate here. What if these numbers were really gigantic and really far apart, and I didn't want to have to graph them? Is there a way to name this exact same vector without graph paper, if I only had the 2 ordered pairs? And there absolutely is, and this is probably one of the most important things about vectors, is you would do head minus tail. All right, so I want vector AB. That means I'm going to take this head, these 2 B coordinates, and I'm going to subtract the tail, which is the A coordinates. All right, so let's take a look at, without the graph, how could you get that 5 and that -2? Well, if I did the x coordinates, it's 3 minus -2. And if I did the y coordinates, it's 3 minus 5. And then you can see where, again, algebraically, where the 5 and the -2 came from.